Welcome to MRL. In this learning session, we'll be learning about the operations on sets, and this is the second part of learning of sets. Okay, now the operations on sets produce new sets. When we carry out certain operations on sets, we produce always new sets, and each operation is well defined. Now let us understand what are the different operations on sets. The different operations on sets are union of sets, intersection of sets, complement of a set, difference of sets, symmetric difference of sets, distributive property, and cardinal properties. So there are various properties to be learnt. Now before we continue with the operations, let us understand what is Venn diagram. Venn diagrams are graphical representation or diagrams of properties and operations on sets. These diagrams were proposed by Venn, a mathematician. In these diagrams, a rectangle represents a universal set, a circle or oval shape represents subsets. These are drawn within the rectangle, and the circle drawn are independent or intersecting. Now, this will be clearly understood with the help of a diagram. So let us understand about the Venn diagrams slowly. Now, the circles are shaded according to the operations on sets, and the diagrams clearly depict the operations on sets. Again, I'll repeat, the circles are shaded, which are drawn within the rectangle, are shaded according to the operations on sets. As per the operations, they are shaded, and the diagrams clearly depict the operations on sets. Now let us study first the operations and also draw the Venn diagrams. Now the first important operation is union of sets. The union set is a set. Please understand, the union set is a set of elements that belong to either of the given two sets or both. The symbol of union is set is U. Now let us take one example to understand it clearly. A is a set of elements 1, 2, 3. B is a set of elements 2, 3, 4, 5. Now if you observe here, in these two sets, the common elements are 2 and 3. 2 and 3 are common. So write 2, 3. The remaining elements are 1, 4 and 5. So all that means elements 1, 2, 3, 4, 5 form the union of set. That means the union set is a set obtained by writing the common elements of the two sets and the remaining elements. Remember that. Now, drawing the Venn diagram of union of sets. First of all, draw a rectangle, draw two circles. One circle represents the set A, another circle represents the set B. The elements which are common are 2 and 3. So write 2, 3 in the overlapping region of the two circles, and the remaining elements of A are written in the circle A, and remaining elements of B are written in the circle B. So 1 is the element of A, 4, 5 is the element of B, 2, 3 are common to both A and B. Now shade both the circles as shown. So this represents A union B. So if you see the elements here, 1, 2, 3, 4, 5 within the shaded region form A union B, which are the elements in A union B, and that is how we represent the union of sets by the Venn diagram. So please remember that. Now coming to the next important operation, intersection of sets. A set of common elements of the given sets is intersection of sets. The intersection of sets is represented by inverted U, and let us understand this with the help of an example. If A is a set of elements 1, 2, 3, B is a set of elements 2, 3, 4, 5, intersection means the element which is common to both. The elements common are 2 and 3, therefore A intersection B is a set of elements 2 and 3. So we have to take only the common elements here. Now the Venn diagram is, again draw a rectangle, draw two circles representing A and B. Now they are intersecting here because there are common elements 2 and 3. So in the common region write 2, 3. The remaining elements of A and B are written in respective circles, and only shade that region which is overlapping, because the elements are only the common elements, 2, 3 are common. So shade only the common region, and that represents the Venn diagram of intersection of sets, and very clearly it indicates us A intersection B, and A intersection B is 2 and 3, and that is how we represent the Venn diagram of intersection of sets. Now complement of a set. If U is a set and A is a proper subset of U, please understand this very carefully. If U is a set, that is the universal set, and A is a proper subset of U, then the complement of A is a set of all elements of U which are not elements of A. and the complement of set A is represented as A dash or A raised to C. Now let us take one example to understand it clearly. U is a universal set. U is equal to 1, 2, 3, 4, 5, 6 are the elements of U. The elements of A are 1, 2, 3. Now observe here, 1, 2, 3 are common in both U and A, but the elements which are not in A but in U are 4, 5, 6. Therefore, the complement of the set A is A dash, and A dash is a set of elements of 4, 5, 6. Therefore, it's very clear the elements which are not in set A but in set U is known as the complement of set A, and therefore A dash is 4, 5, 6. And this can be drawn represented by the Venn diagram. So draw a rectangle, draw one circle, that is A, because set A is there, and write the elements of A 1, 2, 3 within the circle. The elements which are remaining, that is 4, 5, 6, right in the what you call the rectangle, within the rectangle, that represents the universal set. So if you see all the elements 1, 2, 3, 4, 5, 6 represent the universal set, and only shade those elements which are now which are not in A, and those are the elements 4, 5, 6 that shade it. It indicates very clearly it is the complement of A, that is A dash. The shaded region represents A dash. So A dash is equal to 4, 5, 6. That is how we represent the complement of a set. Now difference of two sets. If you have a set A and set B, then the difference of two sets is A minus B, and also represented as A slash with a negative slope. A slash B is a set of elements present in A which are not in B. Now for example, let us take a set A is equal to 1, 2, 3, and that is 1, 2, 3 are the elements of A. B is a set with elements 3, 4, 5. Now A minus B means the elements which are not in B but in A. Not in B but in A. That means the elements which are not in B, which are the elements here? 1 is the element which is not in B, 2 is the element which is not in B, therefore A minus B is 1, 2. Now talk about B minus A. B minus A means the elements which are not in A but in B. If you observe here, the element 4 is not in A, the element 5 is not in A, therefore B minus A is 4, 5. Now this can be represented with the help of the Venn diagrams very easily. Draw a rectangle, draw two circles representing the two sets A and B. And since there is an overlapping element, that is 3 in this, so therefore draw the intersecting circles here with the 3 overlapping both the sets, and write the elements of remaining elements of A, that is 1, 2, remaining elements of B, that is 4, 5. Now we want A minus B. A minus B means the elements which are, please understand, not in B but in A. The elements in A are 1, 2 but not in B, and therefore 1, 2 shade it, and shade that portion of the circle of A that represents A minus B. Now here again draw a rectangle, draw two circles representing the sets A and B. It is intersecting because there is a common element 3. Now we have to represent or shade the circle B, because here we have to find out the elements which are not in A, but in B. 4, 5 are in B, and therefore only we have to shade that portion, and this diagram, which is the Venn diagram, represents B minus A. So that is how we represent the difference of two sets with the help of Venn diagram. Symmetric difference of two sets. This is another very important property. A symmetric difference of B. That means A triangle B, or symmetric difference of two sets A and B, is the union of, please understand, is the union of A minus B and B minus A. So we have to find A minus B. If there are two sets A and B, we have to find A minus B first, B minus A, and then find B minus A, then take the union of that. Therefore A minus B union B minus A is A triangle B. That is what is the symmetric difference of two sets. Let us take one example here. If there is a set A 1, 3, 5, 7, B is a set with elements 7, 8, 5. Find A minus B. The elements which are not in B but in A are 1, 3. The elements which are not in A but in B is only element 8. Therefore the symmetric difference of the sets A and B is equal to A minus B union B minus A, and that is 1, 3, 8. A 1, 3, 8. The union of these two sets is 1, 3, 8. Now Venn diagram of this will be: draw a rectangle, draw two circles, one circle for A, one circle for B. It is an intersecting, they are intersecting circles because 5, 7 and 5, 7 are common elements here. So write the common elements 5, 7 in the overlapping region. The remaining elements of A are written as 1, 3 in the circle A, and the remaining element of B is written in the circle B. And now shade A union B means we have to fully shade it. So therefore we find that 1, 3, 8, 1, 3, 8, that is 1, 3, 8. 1, 3, 8 is A triangle B. The shaded region represents A triangle B. The shaded region represents A, what do you call 1 3 8, and one, remember here the 5 7, that is overlapping region, is not shaded. Overlapping region is not shaded because 5 7 is not to be shaded here. So overlapping region is not, it appears, it looks like it is being shaded, but 5 7 region, that is overlapping region, is not shaded. Only the shaded region is represents 1 3 and 8, and therefore A triangle B is 1 3 8. This should the shaded region represents A triangle B. Remember that. Now there are different properties of sets which we'll be learning in the next part, that is the third part of learning of sets. Okay, thank you.